Good afternoon. My name is Jonathan Casoni, and I am one of the data analyst stakeholders based out of Kansas City, Missouri. Today, I would like to discuss with you the relationship between healthcare data and the impact it might have on criminal activity in Kansas City, Missouri. This is what I plan to cover for this presentation. To reiterate, my dedicated research question asks the following. Considering overall safety in Kansas City, Missouri, how does the improvement of healthcare services, or lack thereof, contribute to the level of criminal activity? To explore this research topic further, I've chosen to analyze two datasets. KCPD crime data 2019 to 2024, which includes criminal activity data from these years, specifically report number, criminal offense and description, date and time of the offense, and location of the offense, etc. And mental health care in the last 4 weeks, which includes the percentages of people who have either received prescription medication, counseling or therapy, both, or the lack of either, as well as the date and location that the data was collected in 4-week increments from 2020 to 2022. For the data preparation process consisting of data conversion, data cleaning, and data munging, I chose to use Python via Anaconda Navigator because it is a widely used programming language within the technology and data mining industries, and there are several resources readily available. I've included my code on the next slide for your reference, and you can also find my code in A1 within Appendix A in my full report. Subsequently, I searched for relevant data and found the crime dataset from Open Data KC and the healthcare dataset from data.gov, of which I was able to download both as .csv files. Given the large selection of crimes within the dataset, I specifically chose to research the stolen automobiles variable because general crimes and misdemeanors likely occur more often in city environments than major crimes such as murder, armed robbery, and kidnapping, etc. With that being said, I chose to drop many variables due to relevancy such as IBRS police report codes, beat number, firearm use, etc., and instead kept variables such as zip code for location purposes, report number, date, offense, and various demographic information. For the mental health care dataset, I chose to analyze the indicator needed counseling or therapy but did not get it as a sample of the healthcare dataset, and to analyze whether people that do not have access to mental health care services are more or less likely to commit crimes. Further, I found that the group by state and subgroup variables consisted of duplicate values that might have skewed the results. Thus, I removed these variables. As a result, I dropped all values besides indicator, state, time period label, time period start date, time period end date, and value. I also dropped records with missing values to clean the datasets. This is my code for data preparation and producing a single merged dataset. Regarding the need for distributed and parallel computing, Huang and others suggest that due to the large amounts of volatile data, bandwidth limitations, and energy limitations, centralized databases are not reliable enough to extract meaningful information in today's digital environment. Therefore, Huang and others and Zhao and others suggest implementing distributed computing to process the workload across multiple systems to perform complex computations, to ensure effective fault tolerance, and to distribute resources efficiently. Considering how distributed computing was implemented in my project, Sandhu suggests the importance of integrating distributed computing within cloud computing environments that consist of multiple computational clusters to handle and to process larger volumes of data. Using Microsoft Azure and Azure Data Studio, I was able to create a cloud-based relational database to implement parallel computing in a cloud-based environment versus an on-prem environment. For my project, the KCPD crime data 2019 to 2024 dataset has about 108,000 rows of data, and the mental health care in the last 4 weeks dataset has about 10,000 rows of data. Therefore, integrating the mental health care dataset, I was able to query the database, producing an output of 132 data points associated with the dataset and 33 data points associated with the indicator needed counseling or therapy but did not get it. Because of distributed computing in a cloud environment, I was able to filter the data based on specific query criteria and contribute to the research question such that the lack of access to mental health care might contribute to higher crime rates. For my data analysis, I chose to implement the k-means algorithm for clustering because I wanted to be able to simplify these two large datasets that I worked with to identify potential patterns, similarities, and correlations between criminal activity and access to mental health care data, contributing to a safer society in Kansas City, Missouri. Using the selected variables, I was able to group together instances of stolen automobiles based on location data. As you can see to the right, this figure illustrates the cluster analysis. I can conclude that most stolen vehicles occur within the zip code 64111, which correlates to Westport in Jackson County. Further, using predictive analytics to forecast the likelihood of stolen automobiles, the figure on the left illustrates a spike in criminal activity within the first 3 months of each year, and similar spikes in the lack of access to mental health care services. Likewise, using the integrated data from the mental health care in the last 4 weeks data set, the figure on the right illustrates similar spikes in the lack of access to mental health care services within the first 3 months of each year as well. However, the spike in September of 2021 might be an outlier based on the resulting data patterns. For example, comparing these two figures, in September of 2021, approximately 18% of people in Missouri needed counseling or therapy, but did not receive it. And there were approximately 575 to 600 instances of stolen automobiles in Kansas City, Missouri during that period as well. It is interesting to note that from March of 2021 to June of 2021, the instances of stolen automobiles are less than 500, as opposed to the rest of the results in the figure to the left. Additionally, from April of 2022 to May of 2022, the instances of stolen automobiles decreased to under 300. Based on the results of each respective data analysis, I can conclude that as people obtain increased access to mental health care services, criminal activity of stolen automobiles lowers as well. This is my code for the k-means algorithm for clustering. Limitations and potential areas for future analysis might include finding data that includes crimes directly associated with mental health conditions, incorporating relevant socioeconomic data such as how education, employment, and housing conditions affect criminal activity and access to mental health care, and potentially, based on HIPAA regulations, how many convicted felons have either been seen for mental health conditions or if they have been diagnosed after the fact. Other conditions of general limitations include data bias, since I analyzed data samples of data population, duplicate values, and missing values. Based on when the dates align within both data results, I can conclude that there is a correlation between the lack of access to mental health care and the occurrence of criminal activity in Kansas City, Missouri. Therefore, I would recommend improving access to mental health care services within the community for those who need or might need the services. In conclusion, this list includes everything I have covered today. I appreciate your time and I look forward to working with you all. Thank you.